Okay, so let's continue our discussion on interest rate risk. Yeah, Matuzio is coming. Uh, so last time we saw the mechanics, right? The mechanisms to estimate duration. So this is not a big problem in modern times because we have Excel, we have other software, whatever we can use. So it's not a problem, but still you have to comprehend how to estimate the duration, right? Although we'll not calculate by hands, of course. And also in your again in your final paper or final assignments, should you have this question, this type of question, of course you will use Excel and not calculate by hands. Okay, so I'll start my screen again. Okay, so last time we stopped at the again the mechanics of estimating duration. So we'll continue with the zero coupon bond. I hope you are familiar with the zero coupon bond. Any idea here? Maybe starting from Tim. What is zero coupon bond?
I'm not quite sure what that is, to be honest.
But you can guess from the name. Zero coupon bond means what? This is a bond that has like a zero coupon, right? There's no coupon. So again, from
No interest?
no, what's that? No periodic interest. That's right. We have to be a bit careful with saying no interest. Actually, there's interest, there's embedded interest, but they don't pay the periodic interest, right? So this is an important question, right? If you don't receive the periodic interest or interest income, why do you want to buy the bond? Let's say within 1 year, you receive 1,000 euros. Then if you don't receive any periodic interest, how much do you want to buy? Lower or higher than 1,000? You receive 1,000 at the end of 1 year. And how
I
much do
will
you
buy
want to
it.
buy?
I will buy it for a lower price
Lower price, right? Common
because
sense. Maybe
at
you,
the end
yes.
we get the interest rate.
Mm-hmm.
We don't have periodically cash flows, but at the
Mm-hmm.
end we get 1,000 euro back. But
Very good,
with
Karina.
the inflation rate, yeah, you have to calculate the present value.
That's right.
And
That's right. Very good, Karina. Yeah. So that's right, right? That's correct. So because you don't receive any periodic interest income, then you have to buy you have to buy the bond at a lower price than the face value or the redemption value, right? If you are able to redeem the bond at the end of the year at 1,000, then of course you want to buy the bond at a lower price. Yeah, Karina, maybe 900 or 950, right? Let's say 900. So you see, right, within 1 year, actually you are earning, how much is it? 100 per 900. So it's about like what, 15% or something? Yeah. So yeah, we can calculate how much percent is it. But you see, the idea here, we don't receive any interest payment, right? That's why we call it zero coupon bond. So that's why when we try to define the zero coupon bond, we don't say that there is no interest income, but the interest is embedded, right? Embedded in the buying price, because you buy it at a lower price and you will redeem it at a higher price. For example, 900 to 1,000, or maybe 850 to 1,000 or something like that, right? So the idea here is what is the duration of a zero coupon bond? So we'll try to prove it like several days ago. So let's imagine a situation where we have like let's tell me again, if we have like 2 years but semi-annual, how many periods is it? Semi-annual but 2 years.
Four.
Yeah, 4 periods.
4 periods, yes. Okay, so let's create a situation where the redemption value or the face value is 1,000, right? But this is a zero coupon bond, so we don't have any like coupon payment. We don't make any coupon payment, or as an investor, we don't receive any coupon income, right? Every 6 months, but we will receive 1,000 at the end of 2 years. Let's say we bought the bond at maybe 800. So we bought it at 800 and we'll redeem it at 1,000. So we see an embedded interest rate here, right? How much is it approximately? So the interest income is about 200, right? 200 for 2 years. So it's about 100 per year, right? So how much percent is that? 100 per 800 per year. So it's about 12.5%, right? You see, so we don't see any coupon payment here, but actually the buyer of the bond enjoys about 2.5% per year in just like simple averaging or arithmetic averaging, right? 12.5% every year, because we earn approximately 200 for 2 years. So now we are going to determine what is the duration, what the duration is for this kind of bond, like zero coupon bond. So I hope you still remember. We write down again. Duration is, what is the denominator again? Present value of future cash flow, right? I hope you remember. Divided by or discounted back at interest rate, market rate, and then we sum them together. And then on the numerator, you have again future cash flows discounted back at the market rate, but before we sum them together, we multiply each cash flow or each present value of the cash flow by real time. Then we sum them together. Okay, so again, with this kind of situation, you could say that the market rate is about 2.5% per year, right, per annum. You see, like 200 for 2 years, so it's about 100 per year. So 100 divided by 800 is 12.5, right? 12.5% per annum. But be careful here, we are using the semi-annual. Okay, so we'll put into Excel, we did last time. So what is our cash flow here? Nothing. It's zero coupon bond, and we receive 1,000 at the end. And the we find the present value. So the first one, what is it again? 0 divided by, what is our market rate for this one? 12.5% per annum. So
0.02.5 to the power of 1.
to 25%, right? To the power of 1, yes. And then we just make a copy and paste, right? To the power of 2, to the power of 3, to the power of 4. Okay. So we sum them together. We get the denominator, right? Denominator. And now we have to find the numerator. We need the real time. What is it again? Periods 1, 2, 3, 4. Half a year, is it? 1.5 years and then 2 years, right? So these are the real time periods, right? Half a year, 1 year, 1.5, and 2 years. Then we multiply each present value with the real time period. And then we sum all of this and we get the numerator. Okay. So the duration is the numerator divided by the denominator, and we get 2. So what is your conclusion here? What is the maturity again? What is the maturity of the bond?
Exactly 2 years.
And then the duration?
Also 2 years.
Also 2 years. So what is your conclusion? For the case of zero coupon bond,
There's no difference between the duration and the lifetime.
maturity. Yeah, maturity. Yeah, that's right. That's right. So for the case of zero coupon bond, we know that the duration will exactly be the same as the maturity. Why? Because again, we see here we don't have any cash flow, right, until the last period, right? So there's no intermittent cash flow right in the middle. So there's no effect of the present value of each cash flow. And we know, you still remember the meaning of duration, right? This is the weighted average time to maturity with the present value of each cash flow being the weight. So we don't have any weight, right? Because we don't have the present value of the intermittent cash flow. So that's why for this specific case, for the zero coupon bond, the duration is exactly the same as the maturity. Quite easy. And we proved it. Another special case here, console bond. Anyone here has heard of this terminology before? Console bond. What is it? You see the definition here? It pays a fixed coupon each year indefinitely. So what is the meaning here? Indefinitely means no maturity, right? No maturity. So you could imagine under what situation will the government issue this kind of bond? Can you imagine an example why suddenly a government would issue such a bond, right? A bond that pays forever. Forever means whoever holds the certificate or the proof or the receipt of the bond will receive the coupon forever. Where
Maybe
does it?
for
Hmm?
maybe for a pension.
Yes, for pension. Yeah, could be for pension for important job, really important job to the country, right? And any example? What is the definition of a very important job to the country? What kind of service can you do to the country that they will give you this kind of bond that will last forever? Yes, Dina? Say it again.
A politician.
Politician, yeah, could be. Maybe founder of the country, right? Could be, right? Yeah, who has paid very huge service to the country. Maybe I can give you a simple example here. In a difficult time where a country needs a lot of like youth to go to war, I think this is the time that the government usually issues this kind of bond, right? As like appreciation and reward to the family, right? Of the youth, right? The young man who want to go to the war. And remember, I think when the British government had to fight Napoleon in the past, it was a very difficult war, right? One of uh, the toughest opponent or enemy that you could fight with, right? So again, I think the British government issued a lot of console bonds. But you see, right? Although we receive the payment forever, the meaning of the payment or the value of the payment will decline from time to time, right? Let's say in 19 maybe 1940s when they had the Second World War, certain governments issued this kind of bond, and it would pay maybe £1, £1 per month, and at that time £1 might be quite good, right? So if you hold this kind of bond, you will still receive £1 per month forever. But you see the meaning of £1 right now is not that big, right? Right. So you still receive the monthly payment or maybe the semi-annual payment, but the meaning of the payment would decline from time to time because of inflation, of course, right? But you'll still receive it forever. Okay. So we call it console bond. Of course, other situations might appear, like what Dina said, for politicians who paid like huge service to the country, maybe the founding fathers of a country, or some other services. Right? But mostly, I think, in a war situation, a government would issue this kind of bond to attract the families, to let their sons go to the war. So in this situation, console bond, you see, the maturity is infinite. Right? You see, this is infinite. So the maturity is like infinity, right? No, it will be, we call it perpetual, right? No limit, no maturity, but we still can calculate the duration as one plus one divided by the market rate. So again, for the console bond, the maturity is infinite, right? Perpetual, but the duration can be estimated as 1 plus 1 divided by market rate. So we'll see an example here. You see any example? Oh, no example here, but yeah, you could imagine the situation if, let's say, the market rate for this kind of bond has been like 10%. So you could estimate the duration as 1 plus 1 divided by 1%. So how much is it? So 1 divided by 1% is what? Is it 11 or 10?
Yes, the duration is 11.
The duration is 11 years. So although the maturity is infinite, but the duration is 11 years. If the market rate for this kind of bond with this kind of risk characteristics is about 10%, right? The market rate is 10% right now, then the duration is 11 years. Again, you still remember our duration, the characteristics of duration. The shorter the duration, the happier we are, because we could recoup our investment in a shorter period of time. Okay, so we'll start now with the economic interpretation. So we have seen again the two special cases. Those were for zero coupon bond and for the console bond. Console bond. Now we'll go into the economic interpretation. So why do we use duration a lot in finance, accounting, and economics? Because we get a lot of help from the duration method to do the hedging, right, or immunization. You could call it immunization. So you try to uh, immunize yourself against the interest rate risk. So we could use the duration to estimate. So this is the change in price divided by price. So this could be the price of anything. Could be the price of an asset. Could be a price of a liability. Right. So essentially, this is the price of an item. Right. Could be an asset or liability. So we could estimate this as minus duration multiplied by the change in interest rate divided by 1 plus uh, the original interest rate. So the interest rate here is a market rate, of course. So you see, what we are measuring here is the change in interest rate. So the change in price divided by original price. Right? And if you move it here, imagine that this would look like this mathematically. So you see the duration is you could define duration as the sensitivity as well, right? Sensitivity of uh, the price of something, like the price of an asset, uh, to the change in interest rate, right? You see the formula here. So duration is essentially, you see the change in price divided by original price divided by the change in interest rate divided by 1 plus original interest rate. So you can say that duration is essentially the sensitivity of the price of something, maybe the price of an asset, to the change in interest rate, right? So when you move it here, I'll move back the position. Okay, so we could estimate what will happen to the price of an asset, right, or the price of something, if we know the duration of that asset, and we have made a projection about the change in interest rate relative to the original interest rate. Okay, so see an example maybe. Okay, so before we see an example, there are some definitions that uh, could be defined here. So if I move this one here, oh, maybe this one first. So minus duration multiplied by the change in interest rate divided by 1 plus original interest rate. So there's a terminology named modified duration, which is duration divided by 1 divided by, sorry, duration divided by 1 plus the original interest rate. So we call it modified duration. So modified duration is duration divided by 1 plus original interest rate. So this is just like a terminology that will help us a lot in subsequent discussion, right? So I could write it this way now: minus modified duration multiplied by the change in interest rate. Agree, right? So duration divided by 1 plus original interest rate is modified duration. So we could write it this way, right? And if I move the P here, I could move the P here, right? Okay, now you see the change in price could be measured as minus modified duration multiplied by the original price multiplied by the change in interest rate projected, right? So modified duration multiplied by price, this is called dollar duration. Yeah, just a terminology, right? So we could write it this way, right? The change in price could be estimated as minus dollar duration multiplied by the change in interest rate. So these are just reconfigurations of equations, right? You see? So for this one, we are estimating the change in price divided by the original price, right? So it's like the change in the value of something relative to the original value, right? But for this one, you see, for this one, what is the difference here? For this one, we are interested in the change in price only, right? So for this one, for the first one here and the top one, the change in price relative to the original price. But for the second one here, for the bottom one, we are only interested in the change in price, right? See the difference? So let's see an example now. Okay, maybe this one. Yeah. So from our previous calculation, we saw this case, 6-year Euro bond, 8% coupon and 8% yield. You still remember, right? The difference between the coupon rate and the market rate or yield. So in this, again, in this example, they're still the same. So what is the duration? We estimated the duration before using Excel, and the duration was 4.99, or it was about 5 years, right? So the maturity was 6 years, but duration was 4.99, or about 5 years. What is the modified duration again? Do you remember? The duration divided by 1 plus original interest rate. So if we put that example into our mechanic here, we've got 5 years divided by 1 plus, what is the original interest rate? 8%, right here. See the yield. The original market rate is 8%. So you see here, duration divided by 1 plus original interest rate. So we get the modified duration of 4.6, right? 4.6 years. This is called modified duration, right? Duration divided by 1 plus original market rate. So what is our projection? Now the projection says that we are afraid of a decreasing interest rate by 1%. Okay, so now we know the modified duration. Okay, so change in price divided by price should equal minus modified duration multiplied by the change in interest rate. So using the example into the equation here, so minus, what's it again? 4.623. We multiplied by the projected interest rate, the change in interest rate projection, and the story says that they're concerned about 1% decrease in interest rate. So this is minus 1. Right? So what is it? So minus 4.623 multiplied by minus 1%. So we get
4.6%.
4.6 62.
4.6%.
Yes,
Yes,
that's right.
I rounded.
Yeah. Yes, that's good. So be careful. What is 4.662% here? Is the change in price relative to the original price. Okay, so this is like the again, change in price is relative to the original price. Right? But if you want to find or approximate the change in price only, then you have to multiply this one with P, right? You can move it there. So if we want to know only the change in price, this would be modified duration multiplied by the original price multiplied by the change in interest rate. And we know this one is minus 4, so that's 623. And then what is the original price? Let's check here. So the original price is 1,000, right? Assuming that the original price is 1,000 and the projected change in interest rate is minus 1%, right? A decrease by 1%. So now we multiply it by 1,000 and we get what? 46.23 euros. Yeah, so this is the dollar duration itself is this one, right? This is the dollar duration. So is 4.623 multiplied by 1,000 is 4,623. Right, this is the dollar duration, right? The modified duration multiplied by the original price. But if you want to put into delta P, we'll get 4623. So the change in price would be 4623, right? But if you want to know the percentage change in price relative to the original price, it would be 4.62%. Right? It's from what's it? The original price is 1,000, and yeah, after the change, it would be like 1,046 and 23 cents. You could imagine, right? The original price is 1,000, so we'll experience an increasing price by 4.62%, or in the monetary unit, this would be $46, 46 euros 23 cents. So 1,000 plus 46, the new price would be 1,046 and 23 cents. So there are two styles, right? So don't be confused with this. They measure the same thing, but one formula is measuring the percentage change, right, relative to the original price, but the other one is measuring the change in price directly, but they are measuring the same thing, right, actually.
I got a question about
Yes.
the decrease in the interest rate.
Mm-hmm.
In the text, it says it's a decrease of 1%, but how do we know that? So is it always when we calculate it for a decrease of 1%, or does this differ?
There are two possibilities to that one. The first possibility is research by the internal organization, right? So we have a company, then we have a research division that keeps conducting research on this, right? So they have to keep doing research on the interest rate, and then market risk, liquidity risk, and everything. So the first possibility is this research result was produced by our research division. But second possibility is you don't care about the research outputs or research findings, but you base your estimation from something that you are afraid of. Because every company and every person or every company will have different things that we don't like. Right? For example, again, if you are talking about the oil producer right now, what do you dislike? Increasing oil price or decreasing? If you're an oil producer.
When I'm an oil producer, I would like an increasing oil price so I can sell it for a higher price.
So you don't like what? What do you dislike?
I dislike a decreasing oil price.
That's right. Very obvious, right? But if you are a country that imports oil, you import oil a lot, what do you dislike here? Increasing or decreasing?
Increasing.
Yeah, so everybody has different interests, right? You see? So second possibility is you do the estimation based on something you don't like. Right?
But we didn't include the 1% decrease in the interest rate, right? That's what I'm wondering about, because in our calculation, we didn't include the 1% decrease. So I was wondering about what would happen if we take a 2% decrease or something.
Okay, actually we included that. For example, if you're afraid of like 2% decrease, we could estimate again as, remember, delta P per P. What is it again? Minus modified duration times the change in interest rate, right?
Yeah, but in the modified duration, we didn't include it, right?
Oh, that's right. Modified duration is the duration divided by 1 plus original interest rate.
Yes.
So not the change in interest rate, but the original interest rate.
Yeah.
So in our case, what is it again? 4.99 divided by 1 plus 8%, is it? Original interest rate, yeah. Original market rate. So you include this minus 4.623, and if you're concerned about a decreasing interest rate by 2%, then you can estimate how much percent will the price change.
Okay, but the modified duration, this percentage would go for like any percentage change in the interest rate. So we include
That's
the
right.
interest rate change in the calculation afterwards for the increasing price and percentage. But for the modified duration, this is like always for 1% change, right?
That's right. That's right. Because modified duration is only using the original interest rate, not the change in interest rate.
Okay.
That's right.
Okay. Perfect. Thank you.
Yeah. So maybe we have second example here, hopefully. Console bond. Yeah, we can use console bond case. Still remember console bond. So it doesn't have any maturity, right? But we still could calculate the duration. See the information here. The coupon is 8, and the market rate is 8% as well. Easy example. So the coupon rate, so the market rate has not changed, right? Still the same as the coupon rate. So what is the duration of the console bond? 1 plus 1 divided by the original market rate. So we get 13.5 years as the duration for the console bond. And you're afraid of what? One basis point change in the yield. So I would like to introduce the term here, basis point. So 1 BP, basis point, is 1 divided by 10,000. So this is the easiest way to imagine. If I say 1 basis point, just imagine that there are four numbers behind the zero, right? So behind the decimal, there are 4 decimal numbers there. So 1 basis point. So is here maybe starting from yeah, Patrick. So tell me, what if I say 25 basis points? Can you tell me the decimal there? 25 basis points.
0.00025.
Yeah, very good. Right. One more try. Patricio, the other Patrick. If I say 250 basis points,
It will be 0.025.
yeah. Or you can write 250 to make it easier for you, right? So 100 basis points is 1%, right? You could imagine that 100 basis points is 1%, because it's 0.00100. Right? Okay, so going back to our story here. So you're concerned about a 1 basis point change increasing, right? So 1 basis point would be, yeah, these are something like this. So what is the estimation again? Delta P per P, this would be what? Minus modified duration times the change in interest rate. And we know that the modified duration here, so the duration is 13.5. And what is the modified duration? It's the duration divided by 1 plus original interest rate, right? So duration is 13.5 divided by 1 plus what is the original market rate? Be careful here, we have coupon rate here, but this is the market rate, right? The yield, 1 plus 8%. And what is it? Let's calculate. 13.5 divided by 1 plus 8%. So 12.5. Is it correct? Yeah, you can verify, okay? So minus 12.5 multiplied by the change in interest rate, 1 basis point. So 0.001, right? So we get minus 0.00125, or what is it? 0.125%, right? Okay, so that's the change in price relative to the original price. So the percentage change in price, right? But if you want to know, delta P, again, you move the P there, right? But it's not, the information is not given, but suppose that this 1,000, then you just multiply 1,000 here, multiply by 1,000, if the original price is 1,000, or yeah, any other number. If it is semi-annual, like what we did with duration, be careful with the denominator, right? The market rate should be in a periodic rate, right? So in a previous example just now, we saw an annual rate because that was an annual analysis, right? Easy. But if we are talking about semi-annual or quarterly data or something like that, then we have to be more careful, right? Because the denominator has to use the periodic market rate, not always annual. So we saw an example here, right? Have to be careful with this one. The market rate is 12% per year, right? But this is what semi-annual. I see here. Have to be careful. So the market rate is 12% per year, but in semi-annual term, this would be 6%. Right? Just be careful with the denominator. Any question about this one? The delta P per P and delta P. Quite clear, right? In terms of the application of, yeah. So actually, again, once again, they measure the same thing, but in different styles. One of them is in the percentage of change, and the other one is the amount of change. But they measure the same thing, right? Just the rearranging the equation. Any question so far about the use of duration to estimate the change in value of something? Okay, so let's proceed. Now, what is the use of duration method? So one of the like salient uses of duration is for immunization. So if we are talking about like to immunize something, like immunization, it means that we try to be immune from something. So what is the immunity or the immunization that we want from this for the case of interest rate risk, right? So we try to immunize our transaction, our asset, our entity as a whole from the interest rate risk. So we'll see a simple example here. Let's say you have a need for money, right? See the example here. So they need, okay, 1469. Okay. So let's suppose you need, maybe you're a pension fund or you're an insurance company that, in 5 years, this is an example, okay? So the number is arbitrary, like carefully chosen for the sake of example, okay? So in real life, this could be anything, any number. But within 5 years, let's say you need 1469, 1.4 million, or any number like that, right? 1469. So what should you do to make sure that you will have the amount of money and your preparation will not be affected by the change in interest rate? You see, this is the what's that? The basic logic behind the fear for interest rate risk, right? So you prepare your money because you know that within 5 years you need this amount of money, but you are afraid that throughout the process, right, for the 5-year process that you go through, you might be affected by the interest rate risk, right? Maybe interest rate is going up or going down. It will affect your prepared money, right, or your investment process for the 5 years. So what is panacea here? What is the medicine here, based on what we have been learning so far? Then to secure the amount of money that you get within 5 years without being affected by the interest rate risk, then we have to find a comparable investment vehicle that has a duration of 5 years. Okay, so be careful. If you know, this is the principle, right? If you know that you need certain amount of money in 5 years, of course you try to match the investment number so that you have the exact amount that you want within 5 years. But to make sure that your estimate or your projection will not be affected by the interest rate risk, you have to find something that has a duration of the same period as what you really want. So not the maturity, but the duration. So once again, right, if you need the money in 5 years and you want to make sure that your investment process for the next 5 years will not be affected by the interest rate risk, then you have to find an investment vehicle whose duration is exactly 5 years, not its maturity, but its duration. Right? So we'll prove it now. Again, let's see an example here. We need 1469 in 5 years. And yeah, you know that this is an academic example, right? By chance, we had an example where whose duration is 5 years. Do you still remember which example is that? I think, or I can open the Excel again. Okay, you see, this is from our previous discussion. Which one is it? 5 years. This one, right? You see, duration is 499 or about 5. Right. So, what bond is it? 6-year maturity, right? 6-year maturity bond with 8% coupon and 8% market rate. Okay, so of course this is designed by the academic text, right? But see, yeah, beautiful story. Suddenly we find something that we really want. But in real life, you could imagine, right? This is not that simple because you might have to combine a lot of things. Let's say you have the necessity for money in 7 years and 3 months, right? Of course, in real life, nothing is that exact, right? Maybe you need like 7 years and 3 months. So you have to find something with the duration of 7 years and 3 months. And you might not be able to find like one specific thing. So you have to combine maybe 3 things combined to create a duration of 7 years and 3 months. But for the sake of brevity and example here, suddenly we could find something that really fits our need, right? Which is 5 years, right? The duration is 5 years. So you see, we suddenly find something with 6 years, right, of maturity. Okay, so this bond, right, based on our Excel, so that yeah, it has 6 years to maturity, and the coupon rate is 88%, 8%, and the market rate is 8% as well. Okay, so let's write it here again. So 8% coupon rate and market rate of 8%. Then be careful, okay? The coupon rate is the same as the market rate. So this is the coupon payment, right? Coupon payment, and finally the face value or the redemption value, okay? So again, the 80 here is the coupon payment, is 8% coupon rate multiplied by the redemption value. But here, this is the market rate, right? So remember from our previous session, previous discussion, that when we issued the bond, most likely the market rate for this kind of bond with this kind of risk characteristics was 8% when we issued the bond, and that's why we gave a coupon rate of 8% because that was the market rate at that time. But you know, when the time changes, the time passes by, the coupon rate cannot change anymore, but the market rate for this kind of bond with this kind of risk characteristics keeps changing. Right? But in this case, they are still the same. Okay, so this is the situation here, and the duration is 4.99, right, or about 5. So by chance, we find this kind of bond that fits our need, right? Remember what's our need again? Within 5 years, we need 1,469, right? And then we'll try to prove it, what will happen here. Okay, so okay, so we'll get what? 80 and 80 and 1,000. Okay. So now let's imagine, right? Our time horizon is 5 years. Of course, the maturity of the bond is 6 years, but remember again, we need money in 5 years, and by chance, the duration of this bond is 5 years, exactly what we need to fit our need for money after 5 years. So tell me the basic logic, right? We don't need any theory on this. So let's see. Maybe going back to team, okay? Team, every time you receive the 80 here, you see here, 80 in the first year, 80 in the second year, 80 in the third year, and so forth. What will you do with the 80 that you receive?
You will invest the money you get again.
You reinvest, right? So you get 80, you reinvest until the time that you set, right? The appointed time. And in our example here, the appointed time is 5 years because we need the money for 5 years, right? For the next 5 years. Okay, so now you can imagine, right? When I receive 80, I will invest until 5 years. Okay, I receive the money here, I will reinvest until here, right? When I receive 80 here, I will reinvest until 5 years and so forth. Okay, so now this is called what? This is called future values, right? Because you get the money here, right? You reinvest until this point, right? So tell me what is the future value of this one? So 80. So present value, we discount it back, so we divide something. For future value, you push the value to the future, right? So you push the value of 80 now to 5 years from now or 4 years from now. So you multiply something, right? So 80 multiplied by 1 plus, what is the market rate again in this case?
8%.
Here, market rate is 8%, right? To the power of, how many movements is that? 4, right? 1, 2, 3, 4. And then you get something. We use calculator to calculate this, of course, right? But what about the second one? One more example here, this one. What is the future value? 80. Multiplied or divide?
Multiplied with 1 plus the market rate, 8%, to the power of 3.
Yes, very good, right? 1, 2, 3. And then this one to the power of 2, to the power of 1, and to the power of 0. right? Because this one doesn't move anywhere, so to the power of 0, right? So of course we'll use Excel to do it. And to make it easier, I will use like imaginary numbers, okay? Because this would be to the power of 4, right? 4, 3, 2, 1, 0. This is imaginary to make it easy to copy and paste, right? So tell me again, what is it? 80 multiplied by 1 plus market rate to the power of 4, right? 4 times or 4 movements to the future, right? And of course, this would be what? To the power of 3, to the power of 2, to the power of 1, and to the power of 0. That's the purpose of using this, right? Because we could do the copy and pasting faster, right? So to the power of 4, 3, 2, 1, 0, and sum them together here. Okay, so 469, you see, right? 469 is the proceed or result from the coupon income plus the reinvestment income, right? Could imagine, right? So the coupon income plus reinvestment income that you get from the coupon incomes, right? Because once you, like what Tim said, right? Once you get 80, you'll not let the money slip, but you reinvest the 80 and so forth, right? And remember one thing, right? We'll stop here. We'll stop in year 5 because this is the appointed time, right? The time that we set because we need money at the end of 5 years. But still, you still remember, right? The maturity of the bond is actually 6 years, right? Not 5 years, but the maturity is 6 years. So obviously, you still have 1 year to go here. Of course, you stop here because you need the money at the end of 5 years. But again, you still have 1 year to go. And what is the value of 1 year? 80 coupon income, one more coupon income, plus the redemption value or the face value. Right? So you still have like 1080 remaining. And what is the logic now? Actually, you could sell it, right? You could sell the bond at the end of 5 years, but actually you still have one more cash flow to go, like one more 80 to go, and one redemption value. So you could sell it at the end of year 5. So what is the estimate of the selling price? This is very easy. So you stop here, but actually you still have 1080. So you could find the present value of it, right? So 1080, what is the present value of 1080 1 year earlier? So it's divided by 1 plus market rate. What is the market rate again? 8, right? To the power of what?
To the power of 1, I think.
To the power of 1, exactly, right? Because those are cash flows from year 6. We try to find the present values in year 5. So one movement only, right? To the power of 1. Okay, so let's see how much is it. So we'll have another cash flow here. So this would be 180 that we are still going to receive like 1 year later, but we try to sell the bond now because our appointed time is 5 years. Right? So divided by 1 plus market rate to the power of 1. Yeah, you could write it, or you don't need to write it, it's okay. To the power of 1, just to make sure. Okay, so the value of the what's that? Cash flows, right, in year 6, discounted back to year 5 is about 1,000. So if we sum together, so it's exactly the amount that you want, right? 1,469. And of course, again, this is an academic example. The number is smooth. So by accident, by chance, we find something that exactly fits what we want, right? But in real life, of course, this is not that smooth. You have to combine many things to get the exact amount that we want. But this is not the point here. But the point here is that we want to simulate, okay? What will happen if the market rate changes? Okay, the market rate changes. So let's imagine now that the market rate is not 8% anymore. And this is, I think, closer to reality because market rate keeps changing, right? So let's assume that this is something that we don't really like because of the changing interest rate, changing market rate, and it will affect our preparation. Again, right? If the market rate doesn't change, we know that we will have exactly 1,469. That is the amount that exactly matches or fits our money requirement. But what if the market rate changes to 9%? So the market rate has increases from 8 to 9%. Remember, the coupon rate cannot change, right? So the coupon payment and the redemption value will remain the same because coupon rate cannot change anymore. So what is it now? This is not 8% anymore, but all have become 9%, right? The market rate has become 9%. And also this one, and 9%. Okay, so let's do it in Excel. We can do the copy paste, but let's do it manually again to make sure that we could see it clearer. So we still have like 80. This doesn't change or cannot change anymore. Right. So what is the future value now? What about this one? So 80 multiplied by 1 plus the new market rate is what? 9? Right? To the power of 4. Right? From year, you get the 80 in year 1, and you reinvest the money until year 5. So 4 years, 4 movement, right? 4 moves that we do here. So you see, this is good news, right? Because now the money could be reinvested at a higher interest rate, right? So in what's that for the context of future value of each cash flow or each coupon income, this is good news because now we could reinvest at 9%, right? To the power of 3210. And so now you see, compared to the previous case, it's 469, now 478. So better, right? So in terms of the reinvestment proceeds, right? And the original coupon incomes, we get a higher amount, right? 478. So this is good news because of the higher reinvestment rate. So still remember, we still have 1 year to go, but we'll stop at year 5 because we need the money at the end of year 5. But we still have 1 year to go, so we could estimate we could sell the bond right at the end of year 5, knowing that actually we still have like at least two more cash flows, like one cash flow for the coupon income and one cash flow for the face value or the redemption value. So what is it now again? 1080. We find the present value, but now the market rate is 9%, right? Not 8, like in the previous example. The 180, we try to sell it 1 year earlier. So we find the present value at 9% to the power of 1, right? From year 6 to year 5. So only one movement. Okay, so we get, this is the projected bond price at the end of year 5, assuming that the market rate is 9%. So if we sum them together, so 1,469, right? That's why we say that you are immune, right? Even if the market interest rate increases, then you still get in total 1,469. So this is a very important concept, right? But again, in reality, in practice, we have a lot more complications because of the exact duration that we have to match, right? And if this is an academic example, we can easily find a bond or an asset with the duration that exactly matches what we need or what we want, right? So one more example, what if the market interest rate declines instead of increasing? So let's say market interest rate is not 9, but maybe 6.5, 6.5%. So it's from 8 to 6.5. So now your reinvestment rate is lower. So reinvestment rate has been lower, right? Not 8, but 6.5. And also when you try to sell the bond in year 5, right? Actually, you still have one more year, but you try to sell it at year 5, then the denominator or the discount factor is 6.5 because it has been lower. Okay, let's do it. Now I will do copy and paste. So what is changing now? Reinvestment rate, 6.5, right? So 80 multiplied by 1 plus the new market rate, which is decreasing in this example, right, from 8 to 6.5 to the power of 4. Once again, because we get the money at the end of year 1 and we reinvest until year 5. So there are 4 movements, right, 4 years ago. Okay, so we make a copy and paste to the power of 3, 2, 1, and 0. Do you see? Now the total amount of coupon incomes plus reinvestment income is only 455. 455, right? So lower than the previous 2 examples. But what about the selling of the bond at the end of year 5 here? Right, you sell the bond at the end of year 5. Actually, you still have 1 year to go. So what is the present value of 1080? Right, discounted back at 6.5. Right, 1080 divided by 1 plus 6.5% to the power of 1, right, from year 6 to year 5 to the power of 1. So we get 1014. And we sum them together, guess what? We get 1469, right? This is an easy but beautiful example that shows us that if you want to make sure that you are immune, right, you are perfectly hedged against interest rate risk for a certain investment horizon, then you have to match the duration. Right? You have to find an alternative investment vehicle that has a duration exactly the same as the time frame or the time horizon that you want. Any question about the some examples of immunization before we see the use of duration for the whole balance sheet? Quite clear, right? Very easy, because this is an academic example. Okay? Very easy. Suddenly you find something, right? Yeah, when I was a student, I kept thinking in my mind, if the world is so easy, then it would be very nice, you go out to the workplace or investment place and you can find any type of asset that perfectly matches what you want. But unfortunately, again, in real life, you have to do some combinations. Right? Cannot simply find, something that easily matches or fits our investment horizon or something like that. Okay, so I think this is the last part of our discussion. So what about balance sheet immunization? So far we have seen a lot of examples that dealt with like individual assets, individual assets immunization. We saw one by they were not part of a balance sheet, right? We saw the bond, right? Zero coupon bond, console bond, and then lastly we saw the investment need in like 5 years or something like that. But now we're going to see how the duration method works for the whole balance sheet, right? for the whole balance sheet. So this is very complicated in real life because now you need the market value of your balance sheet, right? The market value of your balance sheet. Okay, so let's imagine we have a balance sheet. So for our assets, we have a lot of items, right? Maybe hundreds or even thousands of items. Let's name it like asset number 1, right? Asset number 2, asset number 3, and so forth, right? And also on the liability side, you have maybe hundreds of liabilities, right? Debt number 1, liability number 2, 3, and so forth, right? You have a lot. And you could imagine that every item has its own duration. So I could call this one duration of assets 1, duration of assets 2, duration of asset 3, right? This is duration of liabilities 1, duration of liability 2, and so forth, right? So how could we define like duration of the assets? Could imagine, right? This should be what? Weighted average, right? Weighted average. So what is the duration of the whole assets here on our balance sheet? This would be, you could imagine a duration of asset number 1 plus duration of asset number 2, right? Plus duration of asset number 3, and so forth, right? But before adding them together, we have to multiply each of them by its respective market value, or what's that? Market value proportion. So you see here, of course, we have the market value of asset 1, market value of asset 2, market value of asset 3. So I want to tell you, right, in academic context, it's very easy because, if you have an exam, the exam paper will tell you, right, this is the market value of asset 1, the market values of asset 2, 3, and so forth, right? But in real life, you have to calculate by yourself, right? And estimating a market value of something requires a big work, right? If you do like a consulting work to determine a value of something, right? Even 1 month work will require something like maybe 10,000. I think that's already the cheap consultant will still charge about 10,000 per month just to estimate the market value of something, of one item, right? So you see how costly in terms of energy, money, and everything, just to determine the market value of one item. And see here, if you have a lot of items, then you have to determine the market values of everything, right? Of all of them. And then we have, of course, in total, we have the market value of the whole assets, right? So what is the weight for this one? So this is what? Market value of asset 1 divided by total market value of the whole assets. You see, this is a market value proportion of asset 1 relative to the whole assets. Right? So what about this one? What is the weight here? Market value of asset 2 divided by the total market value of the whole assets. Right? So this would be market value of asset 3 divided by the whole market value of assets, and so forth, right? So you could write it this way. Duration of the assets would be duration of the asset component, right, number I, multiplied by its proportion of market value, right, and then we sum them together. So this is the weighted average of individual assets duration. And what is the weight? The weight is the market value proportion of that asset relative to the whole market value of the assets. So let me try now. Tell me how to determine who's here. Maybe Karina, okay? Karina. So with the same logic, tell me how would you determine the duration of the whole liabilities?
I would multiply the market value proportions with the duration of the liability.
Okay, let's give example, maybe 2 liabilities. So we have liabilities.
The market value of the first liability divided by the market value of all.
Very good.
And multiply with the duration of the first liability.
Yes.
And plus the market value of the second liability divided by the whole market value, multiply with the duration of the second liability.
Yeah, and so on, right? Very good, very good.
Yeah.
Right? So you can see, it's very easy to estimate, right, for the academic context. But in real life, can you imagine? You have to determine one by one, right? Each item's market value, and that's really costly in terms of energy, money, resources, and everything, right? But again, in academic, in exam, this would be very easy because you will be informed, right? You have the information readily available on the exam paper. Okay, so now let's see. We have known the duration of the whole assets and the duration of the whole liabilities. So I will continue now. We have this one. So for accounting students, this is very easy. So assets should equal what? Maybe who is it? Maybe Tim? What is it again in accounting? Assets should equal
basically the whole other side.
Liabilities plus equity. Right? So if I rearrange, equity should equal assets minus liabilities. Agree, right? Okay, so now this is something that the stockholders or the owners of the firm don't like. Right? Change in equity value, especially a negative change. Right? If the change is positive, of course they love it, right? No problem with it. But if the change in the equity is negative, then they will be very unhappy, and there will be a lot of like commotion. You see what is happening right now with SoftBank? Do you follow the news, right? So SoftBank is going to sell its stakes at what's that? The telecom, right? The telco company. They try to sell a bulk of stocks to Deutsche Telekom. Yes, no, they don't do well there. The stock price and everything. So, of course, the equity holders will not like it, and there will be a huge pressure for the company to sell the stocks or to be acquired by another company. Okay, so so delta equity would be delta assets minus delta liabilities. Right? Okay, now we will apply this principle. You still remember when we talked about the delta P divided by P? This would equal what? Minus duration multiplied by the change in interest rate, right? Divided by 1 plus original market rate. Okay, and if I move it here, it will be like this. Okay, now apply it to assets. Who is it? Clara, maybe Clara? Can you tell me, Clara? Yeah.
I don't know how you mean how to apply it
Just
to
the same analogy with this one, delta P per P. Now we are doing delta assets, the change in asset value divided by the original asset value. It's just the equivalent equation.
So it would be delta A divided by A minus or
Minus what?
minus
Duration of the assets.
yeah.
That's what we did above. I still remember, right? Duration of the assets, duration of liabilities, right? The duration of the whole assets. Okay. Yeah. Continue. Multiplied by.
Is it multiplied by the equity?
Not equity, but we are doing like equivalent equation as this one. So multiplied by the change in interest rate divided by 1 plus original interest rate, right? Just the same pattern, you see, right? So we'll move the we'll move the assets here.
Oh, okay.
So Clara, tell me now, what about this?
So that would be the same minus duration of the liabilities multiplied with the change in the interest rate divided by 1 plus original interest rate, and then we could move the original liabilities, multiply them with the duration.
Right. Okay, easy, right? Just the same. See, before we go further, you can imagine if interest rate is going higher, right? Even without numbers, okay, without any calculation, if interest rate increases, then our assets will suffer, right? The change in assets will be negative because you see here, negative, right? Negative. So the value of assets will go down. Right? Maybe you have studied this in like financial management or something like that. So increasing market rate will lead to decreasing value of an asset. Right? There's like inverse relation. Right? You see we'll see more about this in subsequent chapters, but you see the logic, like the increasing market rate will lead to decreasing value of an asset. But for this one, liabilities, this would be the opposite. So obviously, we don't need this, I think. Okay, because that's the opposite way, right? But still we put negative here, but see the logic that this is the opposite. The higher the interest rate, the lower the value of the higher the interest rate, the lower the value of the liabilities. So we are happy in that case, right? But increasing market rate, not the coupon rate. Okay, so let's put them together. You remember this one? Okay, so delta equity would be delta assets minus delta liabilities, and we just determined both of them, right? So this one minus this one. So what is it again? Minus duration of assets multiplied by assets multiplied by the change in interest rate plus 1 divided by 1 plus original rate, right? Minus what is it? Tell me, what is it again? Minus duration liabilities
Multiplied with the liabilities. multiplied with the change in interest rate divided by 1 plus original interest rate.
You see here, because they're the same here, firstly we'll take them out. I will take them out because the same, and assuming that the change in interest rate on assets is exactly the same in as the change in interest rate on liabilities. If they are not the same, then we have to do it separately, like what we did for the pricing model. Right? So this is assets, right? This is assets and this is liabilities. So in order to make them the same, we can use some accounting logic. Okay, you see, remember that assets is what? Liabilities plus equity, right? Remember, right? So how to make liabilities into assets? You see the mathematical configuration. Okay, if I try to make this into assets, I could say this, right? Do you agree? Liabilities divided by assets multiplied by assets. What is it? Liabilities, right? Okay, just a different way of mentioning this. So I will write it this way. Liabilities per assets multiplied by assets. Okay, so I could write you see, minus duration of assets okay, minus duration of liabilities, right? And for the assets, this is easy. Imagine, right? Duration of assets multiplied by assets, right? But what about liabilities? For liabilities, we have this one, but we need this, right? We need you understand what I'm saying, right? This is just a mathematical trick, right? To make sure that we have the same assets here. Oh, to make sure that we have the same subject, right? Assets here, but here we have nothing here. But for duration of liabilities, we have L per A. So the debt ratio, right? Liabilities per assets, right? Debt ratio. Okay, and then you see this is negative, and this is positive, right? So negative, positive, right? Negative multiplied by negative is positive. Okay, so we get this formula. So yeah, I just try to explain to you, right? The formula that you see on the textbook is not coming from the sky. Okay, you could trace it, you could do it by yourself, right? It's very logical. Okay, so nothing is to be memorized or something. But if you know the logic, you could imagine and you can memorize by accident. Okay, memorizing by accident means that you suddenly memorize because you could see the logic, and yeah, you don't really try to memorize like crazy. Okay, so we'll continue a bit. Okay, maybe 10 or 15 minutes. Okay, we'll try to finish off. So let's see an example quickly here. Duration of assets is 5 years, the whole assets, okay, on the balance sheet. Duration of liabilities is 3 years. Okay, we put into the equation here. Remember? So here minus, right? Duration of assets minus duration of liabilities. But we have to multiply first by the debt ratio, liabilities to assets, right? Multiplied by assets, right? And then yeah, multiply by this one. So I should say it more accurately here. Because we have the same. Let's say again we have the same change in interest rate divided by 1 plus original interest rate. Right, so they're the same, so we get it out, right? Get it out. So yeah, we saw it here before. They're the same, so we put it yeah, because this is from the negative side, this is from the positive, so they don't negate one another, but we have to get it out. But before we go to the example, one thing that I should ask you to imagine is that you see that three components here. This is the first component, the second component, and the third component, right? So tell me, if we want this to be zero, right? If we want the change in equity to be zero, we have three possible components to handle, right? The first one is this one. Let's start from the right side. So the change in interest rate divided by 1 plus original interest rate. Do you have control over this? Patrick, do you have control over the change in interest rate?
No, I don't think so.
You don't think so? So this is impossible, right? Impossible to handle. This is beyond our control because we are just price taker, not determiner of interest rate. What about this one? Can you make this into zero, your assets? Can you make your assets to zero, Patricio?
I don't know. Like they depreciate, but they cannot keep the value.
That's right. Yeah, but simple question, right? If you have a business, can you make your assets zero to continue the business? Is it possible?
It wouldn't be useful, but you could sell everything.
Yeah, but
yeah, but that's not, I think, not practical in business, right? Nobody will do that. So we can say that this second component is also impossible to make zero, right? So the only component that we could handle is this one, right? If you want to make sure that the equity value is not affected by the change in interest rate, only this component could be managed or could be hedged, right? That's why we go back to our example now. Okay, so duration of assets, 5 years, right? And then the duration of liabilities is 3 years. But remember, you have to multiply by the K. K is the debt ratio. So what is the debt ratio in this example? 90 per 100. 90%, right? The debt ratio or the debt to asset ratio is 90%, right? 90 per 100 multiplied by A. What's the value? What's it? The size of assets is 100 here, right? 100. And then the change in interest rate that you're afraid of is 1%, right? The change is positive 1 divided by 1 plus the original interest rate. What is the original interest rate again? From 10, right? This is the original interest rate. So you put into calculation. So minus 5 minus 90%, 5 minus 3, but multiplied by 90% first. Multiplied by the value of assets, multiplied by the change in interest rate divided by 1 plus original interest rate. So suddenly you find out that the equity value will decrease by 2 million for nothing. Remember, this is not your mistake, right? You could argue that you did nothing wrong, and suddenly the equity value evaporates by 2 million just because of an increasing interest rate by 1%. And you could be pissed off, right, because of this situation. So what is, again, coming back to our story here, what can we do here to make it 0? We can only play with this component. Because the other two components, one of them is beyond your control, and one of them is impossible to make 0 because these are your assets, right? You will not make your assets 0 because it means that you close the business. So what is the logic now to make it 0? So we have this, right? Minus duration of liabilities multiplied by debt ratio. So to make it 0, so we move, so let's get it out. Correct, right? So we move it there to make it 0, right? So duration of assets should equal duration of liabilities that has been multiplied by its debt ratio. Okay. So you could play around with the number, right? So to make sure that the equity, delta equity is 0, you could change. You could change the situation where the duration asset should match the duration of liabilities that has been multiplied by it has been adjusted by its debt ratio. One more thing here. So delta equity is something that stockholders or owners are interested in, but to the regulator, right? To the regulator, for example, the Financial Services Authority, right, or central bank, right? They are more interested in this ratio instead of pursuing delta equity to be 0. For the regulator, they care more about this. So equity to asset ratio is known as the capital adequacy ratio that we are going to see in subsequent chapters. Capital adequacy ratio. So it's roughly equity to asset ratio. So they care more about this. So if you want to make sure that the equity to asset ratio, the change in equity to asset ratio is 0, then we can pursue this one. So you see the difference, right? There's a big difference. If you pursue the delta equity to be 0, then you have to match the duration of assets with the duration of liabilities that has been adjusted with the debt ratio. However, if we want to make sure that the change in the equity to asset ratio is 0, then we have to match the duration of assets with the duration of liabilities only, without the debt ratio adjustment. Right? See, they are two slightly different things. Okay, so what are the weaknesses of the duration model? So firstly, duration matching can be very costly. So we talked about this with from Karina's explanation or the expounding about the duration of liabilities. You could imagine we have to determine each market value, right? Each item's market value, right? So imagine that you have to determine like the market values of all the items on the asset side and also on the liability side. That could be very costly, right? And it's like asking, could imagine in your financial institution, you have excellent people there. It's like asking Lionel Messi, right, a good striker, to be a goalkeeper. You could imagine, right? He's very good at scoring, and you ask him to be a defender or a goalkeeper. That's really no, not useful to the club, right? To your company or to the soccer club, right? So secondly, see here the weakness here. Immunization is dynamic problem, right? Dynamic problem. If you do it tomorrow, all the figures will change. If you do it next week, all the estimates will change. So it's keeping the balance between the accuracy and the timeliness with the cost, right? With the necessity. Maybe you want to do it like once every 3 months, right? Quarterly, or once every 6 months, but you don't want to do it every week, right? Because this dynamic problem is very costly. And then the third one is very technical, convexity problem here. So I hope you still remember from maybe previous courses. Again, if market rate increases, right? If market rate increases, the price of an asset will decline. Right? We'll see this more in subsequent chapters, but maybe from the previous courses that you have done. Right? If market interest rate increases, then the value of an asset will decline. Right? So we have two major techniques, right, to estimate this one. The first technique is the manual technique that you see in bond valuation. Right? In bond valuation, you could prove that, again, there's an inverse relationship between the market interest rate and the value of an asset. Right? But the second method that can be used, and we have seen it today, we just saw it right now, is the duration method. But you see here, we have a convexity problem. No, convexity feature in real life that cannot be explained by the duration model. Right? So this is the two relationship you see here. This is convex, right? You see the convexity there. It's not a perfect line, not a linear line, but a convex line, right? It's convex. But this perfect line here, this is based on the duration method. And this one, the convex line, is based on the manual method, manual calculation of the change in asset value because of the change in interest rate. But you see here, if market rate, I will discard this one. If market rate increases, what will happen again to the asset value? It will decline, right? It will decline. But you see here, the decline, the decline in the market value is more than the real decline. Okay, so what I'm trying to say is that if we use the duration method to estimate, again, remember the delta P, right? If we try to estimate the change in an asset's value as a result of an increasing or decreasing interest rate, we'll find that if the market rate is increasing and the value of the asset is declining, the decline based on duration method is more severe or more than necessary, more than required by the real calculation or the real value, right, based on the manual method. So it's worse than it should be. That's what I'm trying to say, right? So based on duration method, the decline in asset price because of an increasing interest rate is more severe than it should be based on the manual calculation. On the other hand, if the interest rate is decreasing, see here, if market rate is decreasing, then the asset value will increase. However, you see the problem with duration method, the increase in the asset price because of decreasing market rate is not enough, right? It's lower than what it should be. So this is not really good for both sides, right? If market rate increases and the asset price is declining, the decline based on duration method is worse than it should be, right? But on the other hand, if the market interest rate is decreasing and hence an increasing asset value, the increase in asset value based on duration method is lower than what it should be based on the manual method. Right? So we call it what? Convexity feature, right? In real life that could not be caused by the duration method. Right? So at least we have the three weaknesses of the duration method. So any final thoughts or questions about interest rate risk? We have seen two major methods, right? The first one was the repricing model, right? And this one is the duration model. This is the official model, duration model used by financial institutions. But still, we can use, of course, we still can use the repricing model for quick count, right? Or quick indication of your interest rate risk position. Okay, so any final question for today? Quite clear, right? So we'll continue with our next session. We'll continue with credit risk. Credit risk.